Hello, and welcome to NLP Highlights, a podcast where we discuss recent research in natural language processing. The hosts are members of the Allen NLP team at the Allen Institute for AI. In each episode, we discuss one or more NLP research papers with researchers working in that space. I am Pradeep Desigi, a research scientist on the Allen NLP team at AI2. I work primarily in natural language processing with the goal of building systems that serve human information needs. My recent work focuses on training robust and data efficient NLP models that can generalize across domains, tasks, and languages. Hi, this is a special episode of NLP Highlights in which, instead of discussing a few research papers like we usually do, we will talk about open sourcing language models. We will start by discussing some of the important decisions one needs to make when building a language model and releasing it. Then we'll also discuss the Open Language Modeling Project, or the OLMo project, which is currently an ongoing project at AI2. With me, I have two AI tours. There's Beltagy, the research lead of the OLMo project, and Dirk Groeneveld, the engineering lead of the OLMo project. Welcome to the podcast, isn't Dirk?
Thanks for having us.
Thank you for having us.
Yeah, so let's talk about open sourcing language models. In general, maybe let's start by talking about what it means to open source a language model. Yeah, so what does it mean? I mean, does it mean releasing the data or the checkpoints or the training logs or something else? Maybe can you get us started?
Yeah, sure. So open sourcing a language model means you open source. There are lots of levels, various levels, but completely what we are aiming for in the OLMo project is a completely open source language model, including the training data and the code that generated the training data and the decisions that went into the design of the training data. And the same for the model. So like the trained model, the code, the weights, the training code, and all the decisions and choices that went into building all of the aspects of the model.
We might also add failed runs, checkpoints for failed runs, checkpoints for ablations, that kind of stuff.
Cool, yeah. And in general, when you release all these things, for all the components that go into training a language model, what kinds of new research questions do you think we can answer? Things that are not possible with closed or proprietary language models?
Well, actually, when we started, we looked around to see what we had as starting points. And the thing that's the most useful is if you already have checkpoints for previous runs, you can sort of track your own run along with those previous checkpoints to make sure that you're not lagging significantly behind in performance while you're spending all this money training. I guess that's more of an engineering impact you have from other people open sourcing their work, and we want to contribute in that vein as well.
Great, thanks. Do you have anything to add?
Yeah, sure. So there are two broad research questions here. How do you build a language model, and how you use it in an application or in a downstream task? And both of them have lots of open questions. If we are only able to use language models behind an API, that we can only explore one question, which is how to use an existing language model. And we'll be very limited in the kind of ways and manipulations you can do to adapt the language model for a specific task. So with an open source language model, you can explore so many different ways you can adapt the language model to your task or to your application. And this is a chance for us and for the research community to research the technical details of building these models in the first place.
As we're going along with the OLMo project, I find it surprising how many things we have to guess at based on rumor or based on our own experience, where you would think that it should all be science, it should all be published in a paper somewhere, we should be able to read it and just follow known best practices. But in practice, that's not how it works. And I'm hoping that we can move a little bit further along that route so that the next team that does this has to guess a little bit less.
Can you give some examples of some of those things?
Well, which training statistics should we track over time? Of course, you track loss. We track grad norm. Someone on our team is interested in tracking the cosine distance between parameter norm and grad norm because he thinks that might give us information about whether the model is about to blow up thousands of steps into the future. So if we track all these things and we make the statistics public afterwards, maybe someone else can also look at these statistics and come up with good rules that the next team can follow.
Yeah, that's a great segue into the next question I wanted to ask both of you. Some of the decisions that we need to make when we are training a language model from scratch. You did talk about specific statistics that we want to track during training, Dirk. But even before we start training, I'm sure there are lots of decisions that one needs to make, like what data do you train on? How do you process it? What size of model do you want to train? And how these decisions affect each other. So yeah, can you get us started by talking some of the decisions that you had to make, or the team, the OLMo team, had to make at AI2, and also some of the things that others might have to make?
Yeah, you gave a good summary of the high level decisions. You want to balance the amount of training budget you have, the number of GPU hours you have, with the data set size and the model size, and with the model size, and also with the available human resources and engineering and research time and people time that you have to build all of these things. So you need to balance all of these things. And within each one of these, there are lots of details. Like given we generally know that we are going to train a decoder only language, an autoregressive decoder only language model. Then there are a huge number of hyperparameters that you need to decide within the design of this model. Do you want to make the model slightly larger and train it on less data, or the other way around? You want to make the model slightly smaller and train it with more data. How much data you have if you want to make the model smaller and train it a little longer? Would you rather have a model be efficient at training time, or have it be efficient at inference time with the model? How would you make the model scale to long sequences? And then there are a large number of like little knobs and tweaks like this on the data side as well. Maybe Dirk can say more about those.
Sure. The reality is that we can do the big training run only once. So we have to be a little conservative. So our general approach is we pick something that is fairly safe, that we know will work, that has maybe been vetted by other teams before, and we place a few strategic bets about things that we could change. So in broad strokes, we're using a PaLM architecture as published by Google. One strategic bet here is that we're betting on the Lion optimizer instead of the Atom optimizer. That has been de-risked at smaller scale by the Mosaic ML team. We're super grateful for that. So we thought we might try it. On the data side, the broad strokes are that it's basically the llama mix of data, or the red pajama mix of data, with some tweaks, such as the semantic scholar corpus that we have great access to, since semantic scholar is an AI2 project. And the other big deviation is Reddit data. There was no Reddit data explicitly captured in llama training, but Reddit is a pretty large, fairly high quality source if you filter it right. So we thought we might give that a go.
Dirk, you did mention the specific optimizers and other training related knobs. Is there anything? I think this would be very useful for someone else building a language model as well. Can you elaborate on what kind of a training framework we're using for the OLMo project?
Everything is built on PyTorch. We are not using DeepSpeed. We're using only FSDP. We found DeepSpeed a little bit hard to work with, so we thought we'd try this. That has been going pretty well so far. I'm struggling to think what other category of thing you would want to go for. I guess we started with the Mosaic ML code base. They have a really great, fairly minimal example of GPT-2 with various configurations of various sizes. And the key thing there is that it's very hackable. Hugging Face is great. They have a lot of different features in their models, and it integrates with all kinds of stuff. But those models are very large. We wanted something that we can very quickly put a bunch of tweaks into. And so that's where the Mosaic ML GPT-2 example has really helped us out.
Great, thanks. Is one of the points that you said earlier that I thought was interesting was how the decisions that we make about training a language model depend on the composition of the team, right? Depending on the size of the team and the number of engineers you have, for example, and the number of researchers you have on the team, the kind of decisions being impacted by those aspects of the team. Can you elaborate on that?
Yeah, sure. So The three limitations we have, or like constraints that we have, are number of GPU hours that we have for training, our schedule when we want to deliver or like finish training the model, and the available human resources and engineering and resource time. And the three of these constraints, they tell us how much we should embed. They influence a lot of the strategic decisions that Dirk talked about. For example, given the amount of GPU hours that we have and the engineering resources and human resources that we have, should we spend more time exploring different modeling decisions or exploring different data decisions and doing data ablations and studying the data set composition? So we decided, given all of these constraints, to focus more on the data side and go with a fairly standard model.
Okay, great, thanks. Right, so the other thing I wanted to talk about related to the modeling decisions is earlier you mentioned that we're following a standard procedure for building language models, or we're building a fairly standard language model, right? What does it mean when you say that? What is a standard recipe for building language models?
So the standard recipe is you start with pre-training the model from scratch for a large number of unsupervised tokens. Then you do some alignment where you fine-tune it on some instruction data, and you continue training on some human feedback. But this is the recipe that seems to be working right now. But we are broadly following similar recipe, but there is no reason that this is the optimal recipe. And this is another important reason why the research community should be researching large language models, and why the research community should be releasing these language models, because there's no reason this is the only recipe, and there's no reason this is the optimal recipe. It's very possible that it is better to put the instruction data inside as part of the pre-training data instead of a separate fine-tuning phase. It is possible that we don't need the human feedback phase, and there are smarter, more clever ways of collecting this data without the laborious human effort and human effort to annotate examples. So yes, so in that sense, I will like following what Dirk said. We are mostly following the standard recipe here, but while the high level standard recipe, while fine tuning or adjusting the knobs in each phase. But we hope that when we make these language models open source, this encourages the research community more to study this recipe and see if there are better ways to do it.
And for us, this is the first time we're training at this scale, so we're a little bit conservative with our choices. But we're having thoughts about what to do next time around, and I'd love to take a few more risky bets next time, maybe on the architecture side, maybe on the data side, and deviate from the recipe a little bit more and see if we can do a lot better.
Right. I can see how these phases in language model training that, as you talked about, as being separate phases, really, they are really interconnected, right? I mean, for one example I keep thinking about is alignment and alignment with human preferences. For example, if you want to ensure that the model does not generate toxic content or misinformation, right? It doesn't make sense to think of it as a post pre-training phase where you're trying to align with these preferences, right? I mean, maybe these things need to be baked into the model even from the initial training itself, right? And I know that there are no good ways or no good answers to questions like these, and it's probably really expensive to train models in many different ways, because it usually takes several weeks to months to train these language models, right? And it takes a lot of compute as well. Yeah, based on what we know so far about how these models are trained, I guess is a question to both Iz and Dirk, what are some of the things that you think are worth changing and trying out some interesting deviations from this?
You mean beyond what we're trying this time around? So the biggest thing I've been trying to push on is I think we need a large open source mixture of experts model. Possibly all of the open source models are dense right now, but there's a lot of buzz around mixture of experts, and it should be explored. If it was just up to me and we could do it a second time, that's where I would go. It is pretty clear if you start reading on it just a little bit that you have to guess at a lot more settings if you do this, learning rates and optimizers to use and exact architectures and so on. It's a lot more in the air. There's a lot more known about dense models. So this is what makes it more risky, but the potential payoffs are huge.
And I will add, so Pradeep, you talking about toxic content specifically and making the model not generate toxic content. So this is a question that touches every aspect of the training of the model, like from the data all the way to instruction tuning and alignment and stuff. And we know that people have managed to train models that would be largely avoid saying something toxic or offensive. But the NLP research community doesn't know the details of how to actually do this. So the approach we are taking right now is on the pre-training data side, we are filtering out a significant percentage of the toxic content. You don't want to filter out everything. You still want to keep something so that the model knows about these things. But you still filter out a significant percentage of it, and this is something that we are ablating on the data side, and when we are figuring out the right filtering method and the best data set composition, then there are two more steps you can do later on. One of them on the alignment side, where you train it on examples that tells the model, don't answer this question if the question is toxic. And there's an easier method that you can do, which is post-processing, which is a post-processing thing. You have a small classifier that checks the output. If the output is toxic, you opt out. The model says, I don't know, or you don't generate this output. You don't serve this output to the user. But the technical details of how to do the alignment, what is the best data set to use to train the post-hoc classifier, all of these things are still open research. One of the specific ways you can do alignment that takes into account toxicity is control tokens. You have examples that tells the model. You have examples that tell the model which content is offensive and which content is toxic and which content is not toxic. And then you train the model with some control token. Then at training time, then at inference time, you change the token, and that will get the model to mostly generate the non-toxic content. And there are so many ways to do this. The control token is one method that's a simplification of reinforcement learning. But and there are even simpler methods that keep showing up. This is another reason that open source language models should be an important thing, because this is where people can start exploring simpler methods that would do the same job.
Great. Yeah. Thanks a lot for that overview. Right. So let's talk particularly about the goals of the OLMo project. We did talk about the goals briefly a couple of times already, but maybe let's try to contrast what we are doing at AI2 with the OLMo project with other similar projects at other organizations. There are already several closed or proprietary language models, and there are also several open source language models as well. And I'm sure many people are already working on more projects as we speak. So can you try and talk about how the OLMo project is different from some of those projects?
Yeah, so a stated goal of the OLMo project is to keep academia and open source developers in the game. We see a lot of formerly public research disappearing behind closed doors, and we're worried about it. OpenAI is publishing less and less. Google is keeping things under wraps, and we're worried that the open community will lose access to state-of-the-art models and artifacts and become irrelevant. A similar thing happened to research and information retrieval, where most of the work now happens inside of Google and Bing and never gets published at all. So we're going to open up the entire process of building the OLMo model, starting with the code and the weights, of course, but intermediate checkpoints, models that were the result of ablations, logs of which decisions were made and why, and so on. And maybe this is a good time to give a shout out to Eleuthir AI, who have been following this approach for a while. We basically looked at that and said, that's great. Let's do more of that.
So a few more things that make OLMo unique. One of them is the hardware we use for training. So we are training on AMD GPUs, while almost all existing language models were trained on NVIDIA GPUs or on TPUs. So we have carefully benchmarked the hardware, making sure it supports things like BF16, which is important for training stability, and flash attention, which is important for training on longer sequences. And we recently started training 7B models, and we are optimistic that the hardware will continue to scale to the 70B scale. Another angle is the pre-training data set design. So given all the text on the web, how do we build the pre-training corpus that gives us the best resulting model? And this is a research question that is significantly underexplored in the literature. It is difficult to study because curating and processing large data sets is a difficult engineering problem. And once you have this data curated, it is difficult and expensive to run many ablations and many experiments to ablate different data design decisions. So this is a problem we are focusing on. We want to find the best setup, want to find the best recipe in terms of filtering the pre-training data, deduplicating the pre-training data, and finding the right mix of the different sources that we can include in the pre-training data set. Another focus for OLMo is scientific documents. While we aim for OLMo to be a general purpose model that works for all kinds of applications, we also want it to be particularly good for processing and understanding scientific documents. So some portion of the pre-training data is going to be from scientific documents. And this is also something that we will consider at instruction tuning and make sure that some of the instruction tuning data is from the scientific domain.
The OLMo project doesn't have one central research question. It ties together several internal efforts that we already had that we're trying to answer separate, more detailed questions. There are some questions about architecture choices that might work, like the Lion optimizer. There's been, even before the OLMo project, a lot of interest at AI2 about the importance of data, how to filter, how to deduplicate, how much code to use. In some sense, each one of these things could be a separate paper. They might not end up being separate papers each, but we don't quite know yet how we're going to distribute the research questions across the ablations that we can run. Oh, I guess one other thing I should mention is energy usage. There's at least 2 people at AI2 interested in measuring the energy usage of large language model training. They probably have their own set of research questions about that.
Do you have anything to add?
So I like to think of OLMo as enabling other research projects that would have been difficult otherwise. I will give you 2 examples. The first is we hope to empower the research on how to close the gap between open models and other state-of-the-art closed models. And we have recent results that show that this gap cannot be closed purely by instruction tuning on top of models like Llama, for example. So we need more capable base language models than what is currently available. And we hope for OLMo to play a role in enabling this research. Another example is less on the technical side and more on the legal and ethical side. So we want to provide an example and maybe a blueprint that other researchers can follow on how to navigate the difficult legal and ethical issues around licensing, releasing models, releasing pre-training data, and also releasing human feedback data. These are difficult questions, and I don't think we will find the perfect answer for all of them, but we can try to make progress here and hopefully make it easier for the community to navigate these issues.
Great, thanks. A couple of times in this conversation so far, I guess both of you mentioned how we started out with projects that or research questions that we were trying to answer at AI2 already, and use those research efforts to contribute to the OLMo project. I think that's a really cool thing about this project, and that's one of the things that I'm most excited about as to how we've organized the OLMo project internally at AI2. We have people from various teams who've decided, mostly bottom up, to work together towards building the OLMo project. Since you've been involved in the project since the beginning, can you give us an overview of how this happened?
AI2 has a large number of talents in the research side and in the engineering side. Everybody was exploring different aspects of NLP and trying to advance the state-of-the-art in NLP research and engineering. Some of these efforts were about how to build the language model, how to study the data, how to evaluate, how to use the language model in some downstream use case. And each one was trying to write a research paper about one of these aspects. And this project is a good way to align these efforts, make them more impactful, and bridge a large number of existing efforts inside AI2, make them more toward a single big goal.
Great, thanks. Yes, as I said earlier, I think it's really cool how the project essentially started bottom up, and we realized that there were people who are already working on answering some of these research questions that are relevant to building the large language model. So yeah, I think it's really exciting. Let's also talk about the external collaborators involved in this project. You already mentioned AMD. Dirk, can you give us an overview of who else is involved in this project?
Yeah, so the big ones are, of course, AMD and CSC, who made the CSC has made the Lumi cluster available to us for this project, without which we couldn't be thinking about the scale that we're training at right now. There are a lot of others. I've mentioned Mosaic ML a couple of times. They have shared a lot of data with us, and we started with their code base. The open source community is absolutely huge in this. If I try to name all the projects, I'll forget one, so I will not try. But I guess Eleuthер is, of course, the biggest one of them. So they have like with the Pythia project, that has made a big impact on us. Also, the Bloom project, which is not Eleuther, but the Bloom project was a big influence for us. And then there are a number of other companies. Surge is one of them for getting instruction tuning data. I'm actually not too clued into that side of things. Maybe Iz knows more about those vendors, the vendors for data, I mean.
Yes, Surge is the primary vendor that we are working with to get instruction data. We explored a few others, but Surge is the most viable one for us right now. And I will add to this that this is a large project that we cannot build on our. I will add to this that we are open to more collaborations, and this is a project that we want to make it available for the open research community. So we welcome more contributions and more collaborations with people. Like, it would be great if more of the open source efforts to build these language models are more coordinated. We explore different research questions, not trying to do the same thing, and pool resources together. Maybe one of us start building the model, and then another one continue training the model a lot longer, which is going to make it to end up with a better single checkpoint. Yeah. So more of these collaborations would be great for us and for the research community as well.
I think that's actually a very important point. Because by its nature, the open source community isn't that unified. It will often happen that different teams are exploring the same questions at the same time. And I think as a community, we can do a lot better if we avoid that as much as possible. I know it's not always possible because people have compute allocations and they need to produce results on a certain timeline, and sometimes you got to train with what you have. But we should at least try, get together and explore different parts of the search space. We've tried that with a number of different efforts, but I know there's more out there. We can always be doing a better job coordinating.
Okay, so the people listening to this podcast, either individuals or organizations, if they're interested in collaborating and helping with this project, how would you recommend they reach out to us?
Most formal way to reach out to us is by filling in a form we have set up for this purpose. There's a link that we can hopefully put at the bottom of the podcast. This is a great way for either companies or other open source efforts to get in touch. The form might be a little bit formal, but we'll route it to the right people. But also just reach out to us on Twitter. I think we're both fairly active there. If you don't want everyone to know, send us a DM.
Great, thanks. Okay, I'll make sure to include a link to the form in the description of the podcast of this episode. Right. Thanks a lot to both of you, Iz and Dirk, for giving us an overview of the OLMo project and also talking about open sourcing language models in general. Is there anything that you wanted to talk about that I didn't ask you?
No, this was great. Yeah, thank you for the opportunity, and it was fun chatting with you about this topic.
All right. Yeah. Thanks a lot.